Hello, good day. This is me, Patricia Ann Saludas de Vera from BS App 331 under Mr. Ruelson Solidum, and this is my performance innovative task. For today's video, I am going to introduce to you the Legendre polynomials. But first, let us define what is Legendre polynomials. So, Legendre polynomials in physical science and mathematics, this is a system of complete and orthogonal polynomials with a vast number of mathematical properties and numerous applications. This is named after Adrian Marie Legendre, who discovered them in 1782. For your additional information, Adrian Marie Legendre made important contribution to special functions like elliptic integrals, number theory, and the calculus variations. So, what is the use of Legendre polynomials? For example, legendary and associate Legendre polynomials are widely used in the determination of wave functions of electrons in the orbits of an atom and in the determination of potential functions in the spherically symmetric geometry. They are solutions to a very important differential equation. What is Legendre polynomial equations? One of the varieties of special functions which are encountered in the solution of physical problems is the class of functions called Legendre polynomials. They are solutions to a very important differential equation. The Legendre equation is like this. Let us look at this picture. And we have 1 minus x to the power of 2 or x squared times d to the power of 2y over dx squared minus 2x. We have the dy over dx plus n times n plus 1. Y is equals to 0. Okay, that is our Legendre equation. How about, as a continuation, the polynomials may be denoted by p sub n of x, called the Legendre polynomial of order n. The polynomials are either even or odd functions of x for even or odd orders n. The first few polynomials are shown below. So here are some polynomials here. We have the p sub o of x is equals to 1. And for the p sub 1 of x is equals to x. And for the p sub 2 of x is equals to 1 over 2 times 3x squared minus 1. And for the p sub 3 of x is equals to 1 half 5x cubed minus 3x. And for the p sub 4 of x is equals to 1 over 8 35x to the power of 4 minus 30x squared plus 3. And for the p sub 5 of x is equals to 1 over 8 63 x to the power of 5 minus 70 x to the power of 3 plus 15x. So these are the examples of few polynomials. So the general form of Legendre polynomial of order n is given by the sum. So p sub n of x is equals the summation of m is equals to 0 minus 1 to the power of m. We have the 2n minus 2m factorial over 2 to the power of n m factorial times n minus m factorial times n minus 2m factorial. So we have the m is equals n over 2 or n minus 1 over 2, whichever is an integer. Wow! Okay, for you to understand more about the Legendre polynomials, so let's talk about how do you get Legendre polynomials. The Legendre rational functions are a sequence of orthogonal functions on 0 to infinity. They are obtained by composing the Kt transform with Legendre polynomials. So, here are some examples of solving Legendre polynomials. The first one is this one. For the problem number 1, let's express f of x is equals to x cubed plus 2x squared minus x minus 3 in terms of Legendre polynomials. So let of f of x is equals to x cubed plus 2x squared minus x minus 3 is our equation number 1. So for the solution, we have p sub n of x is equals to 1 over 2n factorial times d to the power of n over dx to the power of n times x squared minus 1. For differentiation, we have the p sub 0 of x is equals to 1. For the p sub of 1 of x is equals to x, and p sub 2 of x is equals to 1 half times 3x squared minus 1. And for the p sub 3 of x, we have 1 half 5x cubed minus 3x. So, what is x to the power of 2 in this part? So, x to the power of 2 is, you are going to multiply this p sub 2 here to the 1 half. So, you will get 2p2 of x plus 1 over 3 p sub o of x, this one, and x to the power of 3 is equals to 2 over 5 p sub 3 of x plus 3 over 5 from here to here plus 3 over 5 p sub 1 of x. For the substitution or substitute in equation number 1, this is our equation number 1. Look at this one. We have the f of x is equals to 2 over 5 p sub 3 of x plus 3 over 5 p sub 1 of x plus 2. Okay? And we have the 2 over 3 p sub 2 of x, this one, plus 1 over 3 p sub o of x, here. Let's just copy that one, minus p1 or p sub 1 of x minus 3, and p sub 0 or p naught of x, that is the substitute in equation number 1. So therefore, the final answer here is we have the f of x is equals to 2 over 5 p3, just copy that one, and plus 4 over 3 from here to here, you just multiply them, p2 of x minus 2 over 5 p sub 1 of x minus 7 over 3 from here to here, p sub naught or p naught of x. Okay, that is for the problem number 1, and of course the solution. That is expressing in terms of Legendre polynomials. Okay, so let's proceed to the question number 2 or the problem number 2. For the second example, we have the generating function of Legendre polynomials. So we have here the 1, we have p sub n, 1 is equals 1, and for the number 2, we have the p sub n is negative x is equals to negative 1 to the power of n and pn of x. For the number 3, we have the p sub n of negative 1 is equals to negative 1n. And let's have the proof. Okay? For the number 1, let's prove that p sub of n, 1 is equals to 1. So let's start. We have here 1 minus 2x z plus z squared to the power of negative 1 half is equals to the summation of infinity n is equals to 0, z to the power of n, and p sub n of x. This is our equation number 1. So I will put here, this is our equation number 1. I'm sorry for my penmanship. I am not good in writing here. This is my first time to use this kind of app. So let's continue. And we have 1 minus 2z plus z squared is equals to summation infinity n is equals 0, where z to the power of n, p sub n is for 1. Okay? Let's find out. For the summation of infinity n is equals to 0, z to the power of n, p sub n of 1 is equals to 1 minus 2. Negative 1 is equals to 1 plus z2 plus z3 plus so on and so forth. That is series. It's a series. So we have the summation infinity n is equals to 0, z to the power of n, that is the coefficient of z to the power of n is equals to p sub n of 1 is equals to 1. That is the proof that this one is validated already. This is the answer for number 1 or for the part 1. How about for the part 2? We have here for the part 2, we have the p sub n. For the negative x is equals to negative 1 to the power of n, p sub n of x. So let's see. This is just a simple answering. Okay, let's see for this. Replace x with negative x in equation number 1. So, as you can remember, this is our equation 1. You just have to change the positive x into the negative x, like this one. Let's see. 1 plus 2x z plus z2, that is copy paste from here, from number 1. To the power of negative 1/2 is equals to summation infinity n is equals to 0, where z to the power of n, p sub n of negative x, okay, this one. And this is already our equation number 2. Okay, equation number 2. I already write it because it takes time for me to write the answer here. So I already write it. So, continuation, let's have the replace z with negative z in generating function. Same as with this part, replace x with negative x. Same as with this part. So, z, from here, we have the positive z. The positive z, as you can see here, is the positive z. You have to change it with negative z. So, let's find out. We have the summation infinity n is equals to 0, where negative z to the power of n, okay, that is negative already. We already changed the positive into negative, p sub n of x. Because of that, we have the equation number 3, which is summation of infinity n is equals to 0, negative 1 to the power of n, z to the power of n, and p sub n of x. That is our equation number 3. Okay, you just have to change from the positive x into the negative x to get the equation number 2. Same as with the equation number 3. You have to change the positive z into the negative z. So, let's equate the equation number 2 and number 3 to get the final answer. Let's have this one. Summation infinity n is equals to 0, where z to the power of n, p sub n of negative x is equals to summation infinity n is equals to 0, negative 1, z to the power of n, p sub n of x, whereas we have the coefficient of z to the power of n, which is p sub of n of x of negative x, is equals to negative 1 to the power of n, where p sub n of x. Okay, that is our answer for the part 2. Okay, that is already validated for this part. Okay, that is just the same. Okay, let's go to the part 3, and this is the last part. We are going to find x is equals to 1. That is how it is so simple for us. So just find x is equals to 1. Let's find x is equals to 1. So we have the p sub of n of negative 1 is equals to negative 1 of n, or uh, uh, to the n, p sub of n of 1 is equals negative 1 of n. Okay, this is for the number 3. I think that that would be all for this evening. For this day. Thank you so much for listening to my video. I hope you learned something from me, and thank you so much. Have a great day ahead. God bless. Bye bye.